Hi everyone. In today's lesson, we're going to talk about solving systems of equations, this time with a circle and a line. So when solving a linear system of equation, you're asking to solve for the points of intersection. So again, just like with the quadratics, there are three scenarios. Here we have two solutions where the line and the circle meets in two spots, or we have here where the line and the circle meets in one spot. That's one solution. And again, if you remember from geometry, this is called a tangent line, where the line hits the circle in one spot. This is called a secant line, where the line hits the circle in two spots. And then you can have zero solutions, where the line and the circle don't meet at all. So in order to solve these systems, we do need to review the equation of a circle. So remember, the equation of a circle is in what we call center radius form. In x minus h squared plus y minus k squared equals r squared, where my center is h comma k, and my radius is the square root of r squared. So the r squared here, whatever number would be here, we take the square root of that, we get our radius. And see how this is negative h, negative k, and my center is hk? It's kind of like the parabolas with the vertex and the directrix. It's the opposite sign, right? So this center would be switching the signs. Now, if you had an equation of a circle that was all distributed out with the squares, you get the formula in general form as well. So you could be given a circle like this or a circle like this. So let's look at the first example. They want us to solve the linear system. So we can tell that the first one is our circle because we have both an x squared and a y squared. And we can tell that the second one is my line because we don't have any squared. It's just y equals mx plus b. All right, so circles will have both of them squared, where quadratics will only have one squared, right, the x. So here are your steps to solving. You first solve the linear equation for y, and then you substitute into the circle for y. So you substitute the line into the circle. So step one, solve the line x minus y equals 6. So since my y isn't positive, I think I'm going to move my y to the other side. So we've got x equals 6 plus y, and I need to get y by itself, so I'm going to minus 6. So I've got y equals, I'm just switching the side, x minus 6. So step one, solve the linear equation for y, just like this. And now step two, we're going to plug the line into the circle. So we've got x squared plus y squared equals 26. That's our circle. And since y is equal to x minus 6, we're going to plug that in for this y here. We're substituting the line into the circle. So we have x squared plus my y is x minus 6. I'm going to square it and equals 26. So we solve this just like we did yesterday. We have to set it equal to 0, factor, t-chart, and solve. So before I can get into factoring, I should probably double distribute this x minus 6 squared. So x times x times negative 6 times x again, and positive 6, negative 6 times negative 6 is a positive 36, and plus x squared. So let's combine some like terms. I've got the x squared that I could add together. I've got the 6 x's that I can add together. So x squared plus x squared is 2x squared. 6x minus 6x is negative 12x. And then plus 36 equals 26. So the goal, set it equal to 0. So I can minus 26 on both sides. So 2x squared minus 12x, and 36 minus 26 is just 10. Now, this is a trinomial that we can factor. Luckily, it looks like my 2 can be divided out amongst all of them, so I'm going to take out my GCF of 2, and I'll get x squared minus 6x plus 5. And how I got that 2x squared divided by 2x is just x squared. Negative 12x divided by 2 is negative 6x. 10 divided by 2 is 5. And now I can use add multiply because my leading coefficient is 1. So we need numbers that add to negative 6 that multiply to 5. So just for purposes of time, I'll tell you what the factors are. It should be x minus 1 and x minus 5. And we're going to do a t-chart. So 2 equals 0. This one we reject because there's nothing to solve there. X minus 1 equals 0. We can add 1 to both sides. We get x equals 1. X minus 5 equals 0. We're going to add 5 to both sides. 0 plus 5 is 5. So we just found our x values of the points of intersection. So we have x equals 1 and x equals 5. So just like we've been doing for the past couple days, step 3 is going to be to find the y values. So we've got usually plugging into my line is usually easiest. So y equals x minus 6. So let's start with x equals 1. So 1 minus 6 is negative 5. So I plugged in 1 and got out negative 5. So that's one answer. Then I've got y equals x minus 6 again. And this time I'm going to use 5 for x, this one right here. So 5 minus 6 is negative 1. So I plugged in x equals 5 and got out y equals negative 1. So these two that I've starred are my final answers. That would be where the circle and the line would intersect. So maybe this one would be 5, negative 1, and this one would be 1, negative 5. All right, so let's see if we can start another example. Okay, so this one's in a little different form, but the concept is still the same. We're going to plug the line into the circle. So the line has nothing squared, so this is my line, and this must be my circle because I have an x squared and a y squared. So step 1, we always need to get the line into y equals mx plus b. So we've got x plus y equals 5. So we're going to minus x on both sides and try to keep it in mx plus b form by making it negative x plus 5 rather than 5 minus x. Same thing either way. Now step 2, we're going to plug the line into the circle. So I'm just going to rewrite the circle, x plus 3 squared plus y minus 3 squared equals 53. So we're going to plug this y of negative x plus 5 in for that y. So we've got x plus 3 squared plus my y, which is negative x plus 5 minus 3, don't forget this minus 3, squared equals 53. So before I can square things, I can probably simplify inside the parentheses first. So it looks like I can add 5 and negative 3. So we've got x plus 3 squared plus negative x plus 2, because 5 minus 3 is 2, and that must equal 53. All right, so what I'd like you guys to do now is pause the video and double distribute this and double distribute this, and then hit resume when you're ready for the answer. All right, this is what I got. So when I double distributed the first one, the x plus 3, I got x squared plus 6x plus 9. And when I double distributed the negative x plus 2, I got x squared minus 4x plus 4. If you need to pause the video and try to find your mistake, feel free to do so. But now we're going to combine like terms and set it equal to 0. So x squared with x squared, x's with x's, and numbers with numbers. So that would give me 2x squared plus 2x plus 13 must equal 53. Now we know we have to set this equal to 0, so we're going to subtract 53. So 2x squared plus 2x minus 40 equals 0. So we can factor this. Take a minute, pause the video, and then hit resume when you're ready for the answer. All right, this is what I got. All right, so once I set it equal to 0, I took out the GCF of 2, and I used add multiply to find my factors. So numbers that add to this, that multiply to that. I got 5 and 4, and then I solved for my solutions. So remember, once we have our x values, we need our corresponding y values. So step 3, I'm running out of a little space here. We could put it here. Step 3, we're going to solve for y. So take a minute, see if you can do that, and then hit resume when you're ready for the answer. All right, this is what I got. Take a look. I got -5, 10, and 4, 1. If you have questions, we can definitely go over this in class tomorrow. If you're up for a challenge, feel free to try question number 3, and then I can give you the answer tomorrow if you'd like. All right, have a good night.